In the summer of 1845, the British Royal Navy launched the most heavily provisioned exploration fleet in its history. Sir John Franklin commanded the HMS Erebus and HMS Terror, two fortified bomb vessels retrofitted with thick iron plating and steam-powered propellers to batter through the Arctic ice. Below deck, they carried enough preserved provisions to sustain 129 men for 3 years. Armed with the finest engineering of the Victorian era, they were tasked with mapping the final stretches of the Northwest Passage. Instead, the entire fleet sailed into the Canadian Arctic archipelago and vanished. Not a single European returned alive. For over a century, the primary explanation for this disaster centered on a single fatal manufacturing flaw. Early examinations of scattered skeletal remains led to a theory that the lead soldering on the expedition's thousands of cutting-edge tin cans had systematically poisoned the crew, leading to paranoia, neurological collapse, and death. Modern forensic science has entirely redefined this narrative. By looking closer at the cellular level, researchers discovered the true killer was an inescapable, highly localized environmental trap. To understand what actually happened to the crew, we have to look at the mummified remains recovered from the expedition's first winter camp, specifically the fingernails. Because nails grow continuously, they act like a chronological tape recorder, capturing precise dietary and metabolic data week by week. This is a synchrotron X-ray fluorescence scan of crewman John Hartnell's thumbnail. By mapping the trace elements along the growth axis, scientists could read the final months of his life. The scan proved that Hartnell's lead exposure actually dropped over the course of the voyage, remaining within the normal range for an industrialized Victorian citizen. The real anomaly is found in this blue line, which tracks his zinc levels. The scan revealed a severe chronic zinc deficiency. Over-reliance on preserved canned rations, which lacked the bioavailable nutrients found in fresh meat, had compromised his metabolic stability. Zinc is critical for immune function. This profound dietary deficit stripped the sailors of their natural defenses, allowing infectious respiratory diseases like tuberculosis and pneumonia to sweep through the damp, cramped lower decks. The crew was dying of disease long before they ever abandoned the ships. Biological collapse weakened the men, but a meteorological anomaly doomed the vessels. The most precise temperature record of the Arctic during the late 1840s is found in the ancient boreal forests surrounding the archipelago. Trees record the weather in a specialized layer of microscopic cells called the vascular cambium. During warm, favorable spring conditions, the tree rapidly produces large, thin-walled cells to transport water. As autumn approaches and temperatures drop, it shifts to structural defense, growing tightly packed, dark cells. Together, they form a single annual ring. This cellular anatomy provides a perfect climate proxy. Using techniques like X-ray densitometry and blue intensity scanning, scientists can measure the exact physical density of those dark autumn cells. The denser the cell wall, the warmer the late summer was. When researchers extracted core samples from trees across the Northern Hemisphere, they found that the growth rings for 1846 and 1847 were notoriously narrow and porous. The data shows those 2 summers were some of the most brutally cold on record. The proof of this extreme freeze is literally scarred into the wood. This is a frost ring from 1847. When temperatures suddenly plummet below freezing during an active growing season, expanding ice crystals violently crush the delicate living cells. You can see the chaotic, collapsed tissue permanently locked inside the timber. For the Franklin expedition, this sudden, back-to-back hemispheric deep freeze was a death sentence. The brief summer heat required to melt the Victoria Strait never arrived. The ship sailed into a wall of solid pack ice that was thermodynamically incapable of thawing. What planetary geological force possessed the sheer power to cause summer to fail entirely across the hemisphere? The answer was buried miles away in the ancient glaciers of Greenland and Antarctica. Deep within the ice cores corresponding to the early 19th century, climatologists discovered massive concentrations of trapped microscopic sulfate aerosols. These sulfates are the footprint of stratospheric volcanic forcing. When massive tropical volcanoes erupt, they propel millions of tons of sulfur dioxide gas high above the Earth's weather systems. Once in the stratosphere, this sulfur reacts with water vapor to form a dense aerosol veil. This visual model demonstrates how those microscopic droplets quickly spread across the globe, creating a reflective shield that bounces incoming solar radiation straight back into space, dragging global surface temperatures down with it. The early 1800s suffered a relentless cluster of these eruptions, including Mount Tambora. This consecutive atmospheric bombardment triggered an extended negative phase of the Pacific Decadal Oscillation, cooling the North Pacific sea surface and altering the path of the jet stream. Franklin sailed into the climax of a volcanically induced ice age. The 129 men of the Franklin expedition sailed into a decade where the Northwest Passage meteorologically ceased to exist. Today, the highly advanced forensic meteorology used to solve this 19th century cold case has taken on a new, urgent purpose. The exact same methods are now critical for tracking modern anthropogenic climate change. In the extreme high Arctic, where tall conifers cannot survive, scientists analyze the microforests of the tundra. Dwarf shrubs, like the polar willow, grow entirely flat against the freezing ground, yet they still produce perfectly formed microscopic annual rings. By utilizing historical botanical samples preserved from early polar explorations, modern researchers can map these tiny cellular structures to extend the high Arctic climate record all the way back to 1803. Contrasting the suppressed, freezing growth of the 1840s with modern shrub data reveals a new trend. In dry Arctic regions, rising summer temperatures and the loss of reflective sea ice are increasing evaporative demand. The modern shrubs are browning and suffocating from severe drought stress. The silent cellular memory of wood provides the most accurate account of the extreme north, an unbroken biological archive that solved the greatest mystery of the past and now serves as a precise warning for the future.